All right. I think that's a good. I think this is a good moment to also continue a bit more in direction of going back to from the computation back to thermodynamics to the energetic and material substrate of the wall economy, computation including. So I'll start sharing the screen again. Let's see what's ahead of us. Because I was talking about Georges Reagan, and I was talking about how these Breton's position about the Earth layer also recognizes some kind of ontology of metabolisms, if you will. And to Georges Reagan, basically in his account of economic process, he starts first with identifying a sort of metaphysical idealism that is hidden in the roots of modern economics. Because according to him, this idealism is so strong that even thinkers like Hegel can be actually appropriate pharmaceuticals for such a kind of idealism, if dosed properly. It's a kind of idealism that boils down to an assumption that economic processes are reversible. That's basically the main problem of the metaphysics of modern economics, according to Georges Reagan, that every exchange, every economic process is reversible. And Georges Reagan says that this very trivial assumption actually conflicts with thermodynamics, because thermodynamics gives us these two basic, the laws of, there are several laws of thermodynamics. There is 0, -1, then this first and the second one, even a third one. I don't even remember all of them, but basically Georges Reagan is working with these two, which are standardly assumed to be laws of thermodynamics, if you will. You know, thermodynamics understood in this case as branch of physics that studies heat exchange. And so these two fundamental laws of thermodynamics are that the energy of the universe remains constant and that the entropy of the universe at all times moves towards a maximum. And so together they lead to a conclusion. The conclusion is that any energy transformation contains an irrevocable qualitative change. Irrevocable qualitative change. And it's a change of available energy that can be transformed, for example, into mechanical work, to unusable waste energy, which cannot be transformed in anymore, or bound and unbound energy. That's another pair of terminological pair that is used sometimes in this context. And then in thermodynamics, you of course have this famous parameter, which is called, or index, which is called entropy, which is an index of the change from available to waste energy. And so the more energy in the structure exists in this kind of unusable or waste form, the higher is the entropy of the structure. That's the basic reasoning of thermodynamics. So you have some energy in the system, that energy changes from the form of something which can be used to something which cannot be used anymore, some kind of waste energy. And this waste energy is basically that increases the entropy of the system. And so in this kind of perspective, all the processes that fall in the vicinity of thermodynamics are irrevocable. And this irrevocability is really a key term for Georges Reagan in his reasoning about economic processes. It means that despite we observe many local islands of stable entropy or low entropy, for example, our solar system with the Earth and the biota on the Earth, so despite we observe these many local islands of stable or low entropy, the flow of energy in the whole system, in this case the universe, has only one direction according to the classical interpretation of thermodynamics. In other words, under normal circumstances, the arrow of time, globally speaking, points only forwards. Of course, there are many cosmologies that allow different arrows of time. For example, you can in some cosmologies, you can basically go backwards, but let's stay in this kind of standard model, if you will. It's not something like a standard model really, but something which is like a minimal classical interpretation of thermodynamics without making it too complicated. So the economic implications of thermodynamics are what is of our interest now, and especially what are the implications for the Earth layer. According to Georges Reagan, thermodynamics brings into economy an element of historicity. So there is a history entering the stage. And this element of historicity can be best expressed by modeling economy as a process, not as an object. That means diachronically, not synchronically. And this is basically then Georgescu-Reagan's definition of economic process. Because the economic process in his perspective consists of funds, which is length L, you can see it the third from the right, capital K, the second from the right, and the labor power H, the last one in this formula. And those are three types of funds, according to Georgescu-Reagan. And then we have something that he calls flows. And these flows have basically two parts. So there are output and input flows. So the input flows are natural resources, for example, things like rare earths, solar energy. That's R. Then we have materials transformed in production process, such as glass or metals. That's I, which stands for current input flows. And then we have flows that maintain capital, such as spare parts of machines. That's M for maintenance. And then we have output flows of the economic process. That's, for example, commodities taken as products of an economic process. That's the Q. And then we have waste, of course. That's W. And so it is precisely then this non-identity of input and output flows, that the outputs are different than the input, that makes the model truly thermodynamic, since it brings the moment of qualitative change into the process. So there is a qualitative change of inputs to outputs, not just quantitative change. That there will be, for example, some part of the inputs consumed and then the rest would just go out. No, there is a qualitative change. The inputs and outputs are two different separate things. And plus, the second part of that makes the model thermodynamic is that it accounts for waste as one of the output flows in the form of latent energy or in the form of dissipated matter. So in contemporary ecological economics, this is called flow fund model. And this flow fund model has evolved into a vision of economic process as an artificial metabolism in contemporary ecological economics. So for example, take this book by Mario Giampietro, Kozo Mayumi, and Alavgul H. Sorman, which is called The Metabolic Pattern of Societies. And it's this kind of books that demonstrate this kind of vision of artificial metabolism. They demonstrate it by basically making this analogy between organisms and socioeconomic metabolisms. So just as an organism maintains an intake of food from its environment, decomposes it into basic energy carriers and nutrients, and builds new biochemical compounds out of them, and equivalently also maintains an output of waste and residual heat. So an economy can be imagined as a giant metabolism of sorts. And you can hear here also an inspiration by Erwin Schrödinger's thermodynamic definition of life. But of course, some may hesitate to what extent this is too organicist and vitalist ontology of economics. But be it one way or another, I think the crucial implication is that the metabolism can exist insofar as there is an environment that can provide things like sunlight, water, sources of nutrients, or guarantee optimal temperatures and other climate conditions. And so the imperative is to produce or to reproduce environmental conditions that allow for continuation of the metabolic process. And this really needs to be underscored, that the imperative is imposed on the metabolic process itself to reproduce for itself the environment by the way how the metabolism reproduces itself, or more precisely, the reproduction of metabolism and its environment becomes functionally one and the same thing. So the big question then is, in case of the artificial metabolism of the stack, how these environmental conditions should be produced or reproduced, especially when we see that the stack basically makes an environment for itself, that it is something that is an object, an environment in which that object exists at the same time. And such a manipulationist interpretation of thermodynamics has its ontological consequences in the end. I tried to bracket it off for the moment, but now it is a good time to bring it back, because remember the debate with Raphael at the end of the last session, where the argument was that if one demands to treat economic processes in terms of thermodynamics, then you also need to pay a sort of fee or a tax for crossing this threshold. The tax is that you need to socialize nature in some way, in this case, you need to socialize thermodynamics, or at least you have to strip it off of some ontological grip that would allow it to treat economic process in a reductionist or eliminativist framework. So this kind of socializing nature in this particular sense means to inject a part of normativity into the pre-human realm, which is a very anti-Kantian way how to approach normativity, because you do not naturalize social normativity. You do not do this kind of gesture, like, for example, saying that there are some natural, political, ethical, or legal norms. No, as last time I was talking about legal naturalism for a while, and that's exactly the kind of thing that this socializing of nature is not. It is not the same thing as legal naturalism or naturalizing politics or naturalizing ethics. Instead, it is about finding something like a hidden layer of normativity, which is geologically older, so to speak.